I'd like to welcome everyone to this quarterly GTAP seminar for the broader GTAP community. Very pleased to have today Professor Ken Clements. And the book that this seminar was based on was sent to me by Ken, recognizing that this would be something of interest potentially to the community, and we immediately jumped on the opportunity to have him give a talk here. Professor Ken Clements has been at the University of Western Australia since 1981. As a professor of economics, now emeritus professor. He has a PhD from the University of Chicago and has expertise in international finance, monetary economics, and applied microeconomics. He's Distinguished Fellow of the Economic Society, Fellow of the Academy of Social Sciences in Australia, and was awarded a citation for outstanding contributions to student learning from the Australian Learning and Teaching Council. So he's a great teacher, and this book is authored mostly with his former students. He co-authored notably with Henri Theil, one of the classic books in demand analysis, focusing on system-wide approaches, and that's widely cited. Of course, he's published key papers on the demand for many things, but especially food, diet diversity, and the demand for beer, wine, and spirits. He recognized early on the need for economic modelers and other analysts to understand and parameterize the determinants of consumer demand. In his most recent book, co-authored with 5 of his collaborators, he outlines practical approaches to parameterizing demand systems. He's dubbed this shortcut demand elasticities, and the book really hits a sweet spot for many members of our GTAP community who find themselves in need of developing demand elasticities for their economic analyses of whether it's tariff policy, industrial regulation, food waste mitigation, greenhouse gas policy. The consumer responses to these price changes are very important. So I, for one, am really looking forward to today's lecture, and I'm going to turn it over now to Professor Ken Clements. Welcome, Ken.
Thank you, Tom.
Oh, I assume you'll be sharing your screen.
Yeah, let's just get this working. I don't think that's working quite as I wanted it.
Need the full screen. We're not seeing full screen quite yet.
Yeah. Let's see if I can. Let me try to start again. Sorry.
No worries.
Right.
Okay.
How's that?
We're seeing your second screen. If you go up to display settings, I believe, up at the top,
Yeah,
come
right.
down, swap. Perfect. We're in there. Okay. We're on
Very
booze. We see the booze slide.
Very good. That's the one that we want to start on. This is a matrix of own and cross price elasticities on booze consumption, imported booze into the US from Andrew Muller. And the way that we read this is that the rows refer to quantities, columns refer to prices. So minus 0.54 is the own price elasticity demand for tequila, whereas 0.18 is the cross price elasticity of tequila with respect to brandy. So they're substitutes. Now we see here a lot of numbers before us. We see 60 36 numbers and 36 standard errors. So it's appropriate to simplify this matrix as follows. First of all, let's look at the own price elasticities of demand. Minus 0.54 for tequila, minus 0.51 for whiskey, minus 0.63 for vodka. So these are all around minus a half, and the cross price elasticities are approximately equal to 0. So much for the first three beverages. For the second three beverages, this submatrix down here, it's the troublemaker, because the own price elasticities are nowhere near minus a half. So the second group of beverages are troublemakers. So let's simplify this matrix in 3 steps. First of all, divide the 6 into 2 groups. Second of all, put the first group own and cross price elasticities equal to a scalar matrix minus a half times I, identity matrix. Put the off diagonals equal to 0 and leave the troublemakers as they are. So this is a major simplification, of course, because we've reduced the 36 elasticities to 10, substantial simplification. And that leads into what I call the rule of 1/2, that says the price elasticities are equal to minus a half. Consider the demand for each of any equation. So here's a demand function for the consumption of commodity I, depends on income, depends on prices. This is the substitution effect, and this is the role of income. Under the rule of 1/2, the substitution term simplifies drastically to just minus a half. So the n squared price elasticities up here reduce to 1. So that's a big claim to be able to actually pull that off and to do it. It's useful, however. Well, my brief this morning is to convince you that it's viable under certain circumstances. It's useful when not much is known about the commodity in question, and it can also be useful to reduce the dimensionality of large models. Here's a consumer's utility function and budget constraint, which leads to n demand equations. And here's the Slutsky equation that decomposes the total substitution effect into the total effect of a price change into a substitution effect and an income effect. Now, this substitution effect can be further decomposed into a specific substitution effect and a general substitution effect. Now, the specific substitution effect involves lambda, the marginal utility of income, and it involves U superscript ij, which is the ijth element of the inverse of the Hessian matrix of the original utility function. So let's transform that expression into elasticity form, and we get that the price elasticity of demand can be written as the Frisch price elasticity, which holds the marginal utility of income constant. That's the specific substitution effect. And the general effect is this coefficient phi, which is the income flexibility, the inverse of the income elasticity, the marginal utility of income. Eta I, income elasticity of commodity I. Wj, the budget share of the commodity. Now, let's store that in our memories. We'll come back to that in just a moment, but let's turn to what's known as preference independence, whereby this general utility function is written in almost the simplest possible form. It's the sum of n sub-utility functions, one for each commodity. So there's no interaction between the commodities here in generating utility. And this is probably satisfactory for broad aggregates such as food, clothing, and so on, which satisfy the basic wants of the consumer for sustenance, warmth, shelter, etc. Now, under preference independence, as I said, there's no utility interactions, so the Frisch cross-price elasticity goes to zero, and as an approximation at least, the own price elasticity is proportional to the corresponding income elasticity, where the factor of proportionality, phi, is this income flexibility. And this is known as Pigou's law. Now, here's three economists, three very different economists. First, we have Arthur Pigou, who was a Cambridge don, successor to Alfred Marshall, and Pigou was the target of Keynes in the general theory. And for any students listening, Keynes is pronounced Keynes as in brains. It's a good way to remember it. Second economist here is Milton Friedman, arguably the most influential economist in the past 100 years. And here we have Henry Schultz, not Theodore Schultz, who went on to win a Nobel Prize, but Henry Schultz, who was at Chicago in the early days. Now, the link between these three is they all contributed to preference independence ideas. Here's Pigou's original article, and Pigou, of course, was famous for the economics of welfare, where he highlighted the distinction between private and social costs and taxes and subsidies to bring those two costs into a line. Milton Friedman wrote a comment on Pigou's article. In fact, it was a criticism of Pigou's article. Friedman originally submitted it to the Economic Journal, and Keynes, the then editor, asked Pigou to referee it, and Pigou declared that this was rubbish, and Keynes went on to reject it. So Friedman published the article in the QJE, and Friedman was a research assistant to Schultz when Schultz was carrying out the work to write this monumental book of his, The Theory and Measurement of Consumer Demand, or Theory and Measurement of Demand. And Friedman's work, Friedman's results in this paper were included in Schultz's book, and Schultz acknowledges Friedman's contribution. But some years later, Friedman, rather precociously, went on to declare that this is a great book written by Henry Schultz. Even the chapters that I didn't write are great. So Pigou's law, let's go back to that. Price elasticities are approximately proportional to the corresponding income elasticities. So luxuries are more price elastic than are necessities. Now, this may seem troubling when we first think about this rather at length, because the two elasticities deal with different dimensions of the good. The income elasticity deals with the luxuriousness or otherwise of the good, whereas price elasticity deals with the availability of substitutes. But it can be squared with common usage of the language by considering SALT. That's an essential, that is, few substitutes, low price elasticity. And it's also viewed as a necessity, that is, low income elasticity. Contrast that with foreign vacation. That's not an essential because it's postponable, it's got a high price elasticity, and it's not a necessity. So it's got a high income elasticity. So the proportionality between the two sets of elasticities can be understood along those lines. Now, two more steps to go from Pigue's law to price elasticities approximately equal to minus a half. Step number one is that we need the income flexibility to be equal to minus a half. And I've got, or there is, three sets of evidence on all of that. Still some controversy, more on that in just a little while. The second step to derive the rule is that we need the income elasticities equal to unity. And that's easy based on the idea that all income elasticities have to average out to one from the budget constraint, a weighted average, a budget share weighted average of the income elasticities is equal to unity. So to summarise the rule of a half, it's based on preference independence. It's based on the neglect of the general substitution effect, because that's a second order effect. I didn't mention that, but it is. It's based on the income flexibility equal to minus a half, and it's based on unitary income elasticities. These are all strong conditions, admittedly, and early work on testing preference independence mostly came to reject that hypothesis, but it was subsequently shown that much of that research was subject to small sample biases by using asymptotic tests for the test statistics. And in a very highly cited paper, Pigue's law was very strongly criticised by Deaton, but subsequent to that, Saroja Selvanathan considered Pigue's law for 18 OECD countries, and for 15 out of the 18, she was unable to reject Pigue's law. So the sources of values for the income flexibility fee, I've got three sources here. Source number one is time series evidence. Here's the Rotterdam demand model. So we've got N commodities, N equations in this system. On the left-hand side, we have the change in consumption of commodity I weighted by its budget share. On the right-hand side, we have the change in income, theta I coefficient, and the last term on the right-hand side is the substitution effect, change in the N prices, and the coefficients are pi ij's. Under preference independence, that equation for commodity I substitutes or simplifies drastically so that only the own relative price appears on the right-hand side rather than all N prices, and the coefficients attached to that own relative price is the income flexibility again, phi, and theta I, which is the marginal share. Theta I, it's the marginal propensity to spend on commodity I, and this deflator here in this relative price, it's a Frisch price index because it's marginally weighted. So in the preference independence version of the Rotterdam model, the income elasticity or the elasticities can be obtained directly from this equation just by dividing through both sides by the budget share. We get the income elasticity is theta I on WI, the budget share, and the own price elasticity is this first term divided by the budget share, And then we have the general substitution effect here, which we pick up from the Frisch price elasticity and the product over here. So this price elasticity, that's the total substitution effect. First term on the right-hand side is the specific effect, and the second term is the general substitution effect. Now, this general substitution effect term here involves the marginal share. The marginal share is a positive fraction. So we square a positive fraction and we get a second order term. So we can approximate that by 0 so that the own price elasticity again becomes approximately equal to phi times eta I, the income elasticity. We're just left with that term there as the expression for the own price elasticity, at least as an approximation. So price elasticities are again proportional to income elasticities, as it should be under preference independence, which is back to Pigue's law. So far, so good. Let's consider estimating this income flexibility, this key parameter, the income flexibility phi, with time series observations from the preference independent version of the Rotterdam model. It's a constant coefficient in that model. So with time series data for 37 OECD countries, we can obtain an estimate of the income flexibility for each of 37 countries. And here's a histogram of that. They're not all, they're centered. They're not too far away from -0.5, I'd say. There's some dispersion, but not too far from -0.5. Second source of phi estimates involves cross-commodity regressions rather than time series regressions. Because phi is common to all of the n equations in the Rotterdam model, doesn't have an I subscript on it, we can do the following. Define the change in consumption, adjust it for change in income, and define the relative price of commodity I weighted by its marginal share, then we can do a regression of YIT on XIT, where the slope coefficient is going to be the income flexibility at time t. So we're going to get t estimates now of the income flexibility for each of those 37 countries. And here's the histogram. There's quite a lot of dispersion here because underlying one of these estimates is only 9 observations. So we can't have too much faith in any one observation. But they're centered around here. There's a mean of -0.41, median of around about the same. And if we apply exactly the same methodology, but now to the 176 countries of the ICP, the International Comparisons Project, for each pair of countries, we get a similar histogram, lots more pairs of countries. Now, mean of -0.52, median of -0.48, pretty close to -0.5 or close enough to -0.5. Source 3 of phi values is prior studies and surveys of demand equations, and many of these are centered around -0.5 once again. It's still not completely settled, I should say, and for those who are interested, I give details of that in the appendix to these slides. There is, however, some genuine uncertainty regarding phi. There's inherent uncertainty regarding phi because it represents a higher order effect. And in fact, it's a third order derivative of the utility function, and these higher order effects are usually very difficult to pin down. The first order effect is the margin utility of income. The second order effect is the elasticity. And the third order effect is how that elasticity changes with income. Now, possible objections to the rule of 1/2. Objection number one is that it's based on unitary income elasticities, rules out necessities, rules out luxuries, all goods are neutral, no Engels law. Second objection is preference independence, unlikely to hold for many finely defined commodities, which I refer to as micro goods. So here's objection number one in a bit more detail. Engels' law is one of the strongest empirical regularities in economics, which states that the food budget share falls with income. Here's some evidence from the ICP countries in 2017. Some of these poor countries up here spend more than half the budget on food. Some of these rich countries down here spend 10% or less of the budget on food. So it violates Engels' law, assuming that the income elasticity is equal to 1. It would be consistent with Cobb-Douglas utility function, according to which all goods are neutral, but budget shares would then be constant, and that's bad. That's very bad. Response number one, how do we allow for necessities and luxuries? Well, we can do that rather easily just by modifying Pigue's law that says that the price elasticity of demand is bit greater than half if the income elasticity is greater than 1 for a luxury. For a necessity, the price elasticity would be less than a half, whereby the income elasticity is less than a half. So we could modify that appropriately to deal with that objection. Objection number two, micro goods are not preference independence. Preference independence probably works okay for these broad aggregates, food, clothing, etc., whereby there's little substitutability. It's okay, but it's not okay for micro products such as individual food items or individual brands of the same commodity. So response to that objection is to aggregate the micro goods to groups, to broader groups. Divide the N micro goods into G less than N groups of commodities. Boldface Q1 through boldface QG, that's group 1 through group G, and then postulate that the utility function is additive in sub-utility functions that refer to just the groups of the goods rather than the individual goods. So this is known as block independent preferences. So under block independence, what we had under preference independence now becomes simply an uppercase version of all of that, whereby the own price elasticity of demand for the group as a whole is now proportional to the income elasticity of demand for the group as a whole, where the same factor of proportionality applies as before. That's the income flexibility. And this price elasticity for the group is an appropriately weighted average of the elasticities for the micro goods. And this takes into account the interbrand substitutability that all goes on within the group. So for the group as a whole, it's going to be much lower than the individual brands. And similarly, the income elasticity for the group, it's a weighted average of the micro income elasticities. And we can then have, lying below these group demand effects, we could have demand system for the more micro commodities. We could have AIDS for that. We could have the Rotterdam model, or we could have a number of other models for the more finely defined commodities. CES is a popular choice also for those demands for the more micro commodities. So that's a group-wise extension of the previous results. So much for the theory and direct evidence. What about actual price elasticities? Here's 7 broad aggregates: petrol, beer, cigarettes, water, electricity, wine, and spirits. Petrol has price elasticity of minus 0.35, beer minus 0.37, cigarettes minus 0.42, minus 0.46 for water, minus 0.55 for electricity, minus 0.56 for wine, and minus 0.66 for spirits. Median of all of those is minus 0.46. Now, where do these come from, these numbers in this chart? They come from various meta-studies and reviews. There have been a lot of, or have been a number of such studies for beer, wine, and spirits. Now, this slide is, the font size in this slide is deliberately small because I don't want you to read it. The takeaway that I want you to take from all of this is that there's a lot of there's a lot of elasticities, a lot of individual elasticity estimates lying behind these numbers, and these numbers are means or medians from the meta studies. Now, contrast these broad aggregates with micro products. Now, micro products I call down here branded products, and branded products are not a broad aggregate. Branded products have lots of good substitutes. The elasticity of demand for one brand of beer, of course, is pretty high because drinkers could substitute away from that brand of beer to another brand of beer. So it comes as no surprise that this meta-study of demand elasticities for branded commodities is nowhere near minus a half. It's closer to minus 2. So to wrap up on the rule of a half, Dawkins, Srinivasan, and Wally coined this phrase, the idiot's law of elasticities, according to which all elasticities are 1 until someone shows them to be otherwise, or coffee table elasticities, where informal discussions and opinions around the coffee table determine a value of, say, a half or 2 is chosen. Well, I hope that I have been able to convince at least a few of you that a half has more than a coffee table pedigree. I'd emphasise, however, the qualifications to the rule of a half. It's applicable to broad aggregates only, and it's only a guideline. It's not a law, and it's based on certain approximations. Then again, we shouldn't be too apologetic for making approximations because, as John von Neumann said, approximations are the soul of science. Now, a few words on the linear expenditure system. This is a very popular demand model used in CGE modelling quite extensively. It's a beautifully simple model. And one thing that I want to share with you is a certain thing that is a certain property of linear expenditure system that is underappreciated when LES is applied to food. Here's the Engel curve corresponding to LES. The income elasticity is this constant parameter beta, the MPC, marginal share of food, divided by the budget share. So the income elasticity, it's inversely proportional to the corresponding budget share. So if we take the difference between the food income elasticity in, say, a rich country relative to that in a poor country, that's going to be the negative of the corresponding relative change in the food budget share. So we could write that the food income elasticity in the rich country, it's going to be the ratio of that in the poor country to the ratio of the budget share in the rich country to the poor country. Let's illustrate that in a numerical example. Let's suppose the poor country spends 50% of the budget on food, whereas it's only 10% in the rich country. And let's furthermore suppose that the income elasticity of food in the poor country, it's 0.3. It's a reasonable value. It means that according to LES, the rich country is going to have an income elasticity of demand for food of 1.5. So it's above unity. So food is going to be termed a luxury for the rich country, which makes no sense at all. So the warning for LES income elasticities is that the change in the income elasticity, when income changes, it's positive for necessities and it's negative for luxuries. So the villain in all of this is the assumption of constant marginal shares in LES, and this can be problematic when there are large changes in income. I should add that this warning applies to the Rotterdam demand model also, as well as LES, because in Rotterdam, the marginal shares are parameterized as being constant also. How to deal with that? One solution that we've used is piecewise LES, so that we have a separate LES demand system for each income quartile using HES from Australia, the Australian Household Expenditure Survey. And here's the quintiles for the budget share of food income on horizontal, food budget share on the vertical. Here's the marginal share. The marginal share is constant if we have one LES for all of the all income earners, whereas here's the marginal share quintile by quintile. It slopes down as opposed to being the same. So the income elasticity for LES, when we have the same expenditure system for all consumers, the income elasticity of demand for food increases, and in fact it ends up above unity. It's no longer a necessity for rich Australian consumers, whereas if we use quintiles, it slopes down and gets smaller by and large as income increases. And here's the underlying Engel curve constructed on the basis of piecewise linear slopes. So when we use these multiple consumers, that is with piecewise LES, it seems to have substantial impact on the results of CGE models compared to standard default values of the elasticities. Similarly, we've got estimates of elasticity of substitution for intermediate products in our simulations in our book. And finally, we've got estimates of CES sigmas for foreign and domestic varieties of goods. We have simulations of that we have CGE simulations of that in our book also. And all of those three things seem to indicate substantial impact on results when we use those as opposed to standard settings. Thanks for your attention.
Excellent, Ken. Thank you so much. You were right on time. Indeed, you saved a little bit more time for discussion. Excellent. So let's, if you stop sharing, then we can hopefully see people. It'd be great. I'm going to ask first question, but those who wish to ask a question, you can post it in the chat or you can come off. I mean, it'd be great to see you anyway, if you don't mind putting on your videos, folks. So Ken can see the all the different people participating. Ken, let me start out by just mentioning a little about what we've done in GTAP under Alan Powell's influence. So we estimate the ADAD system. You'll be glad to know Alan Powell's legacy. We've done it. We've estimated for 10 broad GTAP aggregates on the using the ICP. We've also estimated it directly on the GTAP database. Obviously, we've got great income variation, the price variations coming off of policies. That ADAD's estimation directly on the GTAP database is what we use to parameterize the GTAP income elasticities and ultimately calibrate the demand system we're using. That seems to work pretty well at 10 goods, as you know, which is what you've described as the broad aggregates. And what we seem to wrestle with mostly I don't think we've come up with really good strategies for nesting below that. The natural thing to do is to come up with, as you said, CES nests. The question is what elasticity of substitution to use, how to group them. But yeah, when it comes to tariffs, fruits and vegetables, it's not fruits and vegetables and nuts. It's almonds from this source. So that's what I think that's the area that probably a lot of people are wrestling with. And we can supply them with the broad aggregates, but the nesting idea, how to think about that, maybe you could just speak a little more. I enjoyed that couple of slides you put in there along that topic. I'd like to look at them in more detail, but maybe you could just talk a little more about this nesting approach.
Yeah. First thing is I'm very well aware of your work. I know those papers very well. They're based on implicit additivity. And yeah, that's a good idea to get at the problem, how to parameterize these things, how to keep things manageable. Now, going down more disaggregated with the foods, we did some work on this with the unpublished ICP data. Not this time around, not the most recent round, because they're not being made available this time around. The 2021, the bank aren't giving them out. But for an earlier version, we got highly disaggregated foods. Just trying to remember 30 plus commodities. We had rice, bread, pasta, meat, vegetables, these sorts of things. Now, we did our best, but we weren't wholly successful in that. We used one of these, or a variant of one of these simple demand systems that were proposed that involved a very simple iteration that would work for very large systems. So we had both the micro or more micro commodities, and we used this simple demand system by, I'm racking my brains to remember who proposed this. Someone out there will know, I'm sure. It worked out okay, but we then had to do a bit of manhandling of the results to make complete sense of it. So I agree with you. That's a challenge. If we use CES, which would be the probably the default way of handling it, we've got some ways of estimating sigma based on time-wise moments. So if you've got a country with T observations, we can get out T observations for capital T observations for sigma, one for each year. It's like a cross-commodity regression approach that we've used before, and we've got results on that in our book. So you might want to take a look at some of that material. That may be the best that can be done, at least for the time being. CES, of course, has unitary income elasticities built in. There are some generalizations, though.
No, that's great, Ken. Thank you. Let's open it to questions from the audience. Anyone want to raise their hand and jump in? Otherwise, oh yeah, David, go ahead, and if you want to come off, yeah, David.
Hi. Hi. Yeah. So it's David Trigger from Wageningen, Social and Economic Research. Thanks very much for this great speech. So my understanding of this shortcut approach, so you highly simplify the need for the parameter, right? The price, especially the price elasticity parameters. You try to estimate a general flexibility parameter phi, and then multiply by the income elasticity. You can get pretty much all the cross and price elasticity. Now I'm thinking maybe it works pretty well with maybe a small demand system, but with a large complex demand system. We have both some similar products and also very different products. Now we think about different foods, also the food and manufactured goods. Now, so technically, I'm thinking how this shortcut approach works in such a large system. Now, for example, uh, uh, for the demand response in wheat, for example. Now, if there's a price change in in grains, now we expect that probably have quite such strong substitute, right? So strong substitution between the two. Now, but what if the price change is initiated from manufactured good, right? That's going to be different. So in this case, it's not just the income elasticity of I, commodity I, which is the wheat in this case, but also depends on the initiating price changes. So where the price changes from? Is it from a similar good or from a very different goods? So we expect this cross price elasticity are rather different, in these two situations. So how can this be handled in your shortcut approach?
Yeah, good question. Thanks, David. First thing I'd say is that whenever we have something which is large and complex, we want to try to simplify it and make it smaller so that it's manageable. So what I would do when you have both manufactured commodities and but almost raw commodities here, I'd group them, put them into groups, and then I would analyse the within group for the manufactured commodities, within group for the raw materials, and then I'd allow for these cross effects via group-wise effects. So we would basically collapse the large system into two smaller, they still may be large, but relatively smaller to what we started out with. Number one, for raw commodities. Number two, for manufactured goods. And then we can have them talk to one another via the group effect, not the individual effects. Now, that requires some structuring of the underlying production function and or utility function, but it's worth a try, I'd say, rather than throwing our hands in the air and saying, this is large, this is impossibly large, impossibly complex.
Yeah, this is exactly
And
what I'm trying to do now.
David,
Sorry.
let's collect some additional points. I think
Yeah.
that's really, you're raising a really good point. And Ken, as a system-wide guy who's at this stage in his career, says, "Okay, let's simplify it." Got to admire that. You know, I see Irwin on. Irwin, the standard GTAP model is set up to, you know, there's this CDE function which works best at 10 commodities, but in fact, that's allowed to operate across whatever commodities you disaggregate in order for flexibility. It would be nice if we had a version of the standard model that was more in the spirit of what Ken is suggesting, that we would have 10 broad aggregates. They always appear in the model. And then you choose how much detail comes below that, and you supply these elasticities of substitution. Maybe you refer to the book, whatever, but you go out and get those and focus on, David's interested in grains, someone else is interested in booze. And I think the setup of the standard model, we could have a variant of the standard model that would cater more to what Ken is suggesting. Do you want to comment on that, Erwin?
Yes, thanks, Tom. That was actually my question to Ken. How will we handle if we're going to aggregate from a disaggregated database towards a more aggregated database? But Tom's solution is actually much better because we already know the groups, and then we can estimate within those groups what the elasticities are within the group and how they relate to other groups. Yeah, no, thanks, Tom. Ken, I have a slightly different question. You mentioned earlier that we should go and do cross-section estimations instead of time series estimations. But we know that for us to get good elasticity estimates, we need a lot of price variations, right, in the data. So does that mean we focus more on assembling price data within that cross-section instead of trying to figure out what the variations are across the time series observations?
Yeah, well, one way to get required variation in the prices in a cross-section, of course, is the cross-country stuff with the ICP. What I was talking about was we've got time series observations, and then we have cross-commodity observations. So when I was talking about cross-commodity observations, we go across the N commodities. We do a regression across N rather than across T, or we do it across T also, but we do it across N at the same time. I did talk about the LES Engel system, which we did estimate with cross-section data, and there what we did was that we didn't have any price variability. So we assumed a value for omega, the Frisch parameter, which is the inverse of the income flexibility. We put it equal to -2 to get our price elasticities out that way, because we've got the income elasticities from the cross-section stuff from the Engel curves. Assume omega is equal to 2, and that'll give all of the own and cross-price elasticities.
Great. A lot of valuable tips. We've got to get this book. Anything else? I got one more question, Ken, if others don't want to chime in. And that is the first matrix you showed us. It was beautiful. I happen to know Andrew Mohammed quite well and have followed his work and very careful. Why not use the full matrix? Okay, it looked like everything was significant. Maybe I didn't catch that. But and then the question is for the CGE modelers, how do we calibrate a flexible functional form to that? That's an intermediate step we have to do to get it into our modeling setting. We need a well-defined preference structure that is globally well behaved. So age doesn't work. We got to go to something that's globally well behaved. But that looked really interesting. That full matrix of Boo's elasticities looked extremely interesting. I wasn't so ready to just discard the cross price elasticities and whatnot, but I just wanted to raise that. That was the first thing I thought was, wow, you have that. Why not keep them all?
Yeah. Look, I don't mean to minimize Andrew's work at all. And yeah, I wouldn't recommend throwing it away at all. It was just a sort of a launching pad. I remember when I saw his paper, I saw this -0.5 immediately, and I sent it to Andrew, and we had a bit of correspondence about it all. So I thought, this is too good not to try out on your preeminent group. But you're right. It looked good. I agree, and I wouldn't want to throw it away also.
No, that was an excellent way to motivate it, though, and it is striking, that rule of 1 minus 1/2. And I've heard the rule of 1 used amongst ag economists as well, which is disturbing. So, this has been fantastic. I want to call attention to people. In the chat, Ginger has posted the link to the book from Springer on shortcut demand elasticities. I think there's going to be a lot of interest in that in this community. Thank you, Ken, for taking the time to share your ideas. This is the kind of bridge that we need more of. We need strong empirical work to back up these policy analyses, especially when it comes to things like tariffs and whatnot, where there are potentially huge price changes, or where you're looking at income growth over time. So really important work, and we need to draw on it more in the future. So thank you so much, Ken, for joining us. Thanks all of you for participating. Hope you go off and read this book and take advantage of it. So take care, everyone, and thank you again, Ken.
Thanks very much, Tom, and thanks for everyone's comments. Thanks for getting up and starting work so early too.
Yeah, it's our pleasure. It was very worthwhile. Okay, take care.